The broadcast is now starting. All attendees are in listen-only mode.
Thank you for joining us for today's webinar, Wide Dynamic Range Camera Technology. My name is Richard Bell and I'm the National CCTV Product Manager at Alarm Corp. Just before we get started, let's run through some general housekeeping. You will notice that you are muted. You will remain muted for the duration of the webinar. Just to ensure that you can see the presentation and can hear me, can you please click on the hand icon? That's great. I can see lots of raised hands. You can lower them now. At any time you can ask questions, and at the end of the webinar I will answer any questions. Just remember to click send after typing your question. Our topic today is an overview of wide dynamic range and how it is applied to a camera connected to a CCTV system. Wide dynamic range cameras are typically referred to in the industry as WD. In the upcoming slides, we refer to the Sony implementation of this technology that is known as ViewDR. How is WDR measured and what to look for in datasheets. The applications of where to best use a WD camera. This is typically an additional cost for a WD camera over a standard one due to the extra processing circuitry involved. WDR means a wide dynamic range of light level. Light changes at different times of the day, and depending on the actual camera location, this change in light can have a significant effect on the output that is displayed. Examples such as building foyers looking out towards a street, or in car park entrances change with vehicles entering in the morning or in the evening with their headlights. In the case of a car park, the concentrated flare that the camera is exposed to from the headlights is a good example of where a WD camera is required, especially if the number plate details are a priority. WDR performance is measured in decibels, i.e. dB. The higher the dB rating, the stronger the performance of the camera. However, the resolution of the camera also needs to be considered. Generally, as the resolution gets higher, the dynamic range gets lower. The rating of a Sony IP camera can extend up to 130 dB for their 1.3 HD range to 90 dB for the 3 megapixel full HD range. It is important to understand light levels. A dark scene might be in the range of 10 to 20 lux, and a bright scene could be in excess of 1,000 lux. A WD camera needs to be able to handle these varying light conditions. A camera needs light in order to generate an image. Whether it is natural, artificial, or an IR illuminator, they all have their challenges. Too much light washes the image out, and too little light results in a dark image. With a normal amount of light, the iris will open its shutter size to get the correct amount of light onto the sensor. A WD camera helps compensate these changes in light levels. Cameras are normally configured in a browser for an IP system at least. A number of manufacturers have their default configurations of enable, disable, or a manufacturer's suggested auto setting. It is also possible to have WDR profiles embedded in the camera. For example, this may be set to a higher value if the backlight is too strong. An important consideration to factor in system design is cost. WD or ViewDR cameras do cost more than those that are not fitted with this technology. The placement of these cameras needs consideration within the installation, and not all cameras need to have this feature. For example, if the camera is in an area where there is a constant light source and is unaffected by outside influences such as the sun, a non-WD camera will be suitable. Saying this, it is important that a WD camera are implemented when the actual environment calls for this. If not, installing an inferior camera that is not suited will result in images that are not clear and unusable when the situation takes place and the recorded footage does not show the incident required. The human eye has the capability to see extremely dark and bright scenes at the same time. A normal camera does not have this feature. The single image shown here is typical of the flare from the outside bright light and where a WD would be best used. This is where the wide dynamic function comes into play, where it gains a similar capability of dark and bright scenes at the same time. There are two basic designs that are used in WD cameras. Firstly, non-linear sensors that are typically logarithmic sensors on the imager that are triggered basically from different illumination levels within the viewable area. Non-linear sensors differ because they allow the captured image in one frame. The second is multi-frame imaging. The camera captures multiple versions of the field of view with each frame at a different contrast ratio. The camera combines the frames to eliminate the darkest and brightest portion of the field of view, producing the WDR frame. Of the two solutions, multi-frame imaging is the most widely used for WD applications because it is more suitable for capturing images in real time and can process moving objects more quickly. Sony have based their WD technology, known as ViewDR, on the multi-image approach. It is a combination of the high-speed exmor sensor and the visibility enhancer, referred to as VE. A Sony camera with ViewDR uses an electronic shutter to capture multiple images to reproduce each frame. One image is taken using a standard exposure time, and an additional 1 to 3 images are taken using very short exposure times depending on the camera type. These multiple images are then combined using an algorithm to form the finished image that is displayed on the monitor. ViewDR nearly doubles the sensitivity compared to conventional WD technologies. In fact, the end result images are extremely visible to the point of being better than what we can see with the naked eye. The following few slides show examples that have been taken directly from a Sony CH140 full body camera. The left-hand side images have ViewDR switched off, and the right-hand side it is enabled. The details on various portions of the screen are obvious when zooming in. The artificial light source in the information sign is the main point that is causing the picture to appear dark, as the camera is trying to compensate for the concentrated bright spot. The right-hand side with ViewDR enabled has far more detail in the overall picture. Again, in this warehouse environment, the natural light outside is the problem. The camera mounted inside the warehouse shows a dramatic improvement with ViewDR in the image on the right-hand side. The detail of what is physically located inside the van is a vast improvement with ViewDR enabled. The previous photos, while they demonstrate the point in still images, a moving target is typical of a real-life scenario in a CCTV system. The reflection of the sun and snow truly show the capability of a camera with wide dynamic range. With the exception of ViewDR feature, both of these examples have been configured with the same camera setup. The first clip does not have ViewDR enabled. Depending on the speed of your internet connection, the person walking along the platform may be delayed. Clearly, in this clip, you will be able to see the difference with the ViewDR feature enabled. This highlights the importance of this technology, and especially in the conditions where the light source is constantly changing throughout the day. As mentioned in the previous slide, if anybody has had a problem seeing this comparison, these two clips are available on our Facebook page. WDR technology is not limited to just IP cameras. It is available for analog systems. These images here are taken directly from an Interlogix XP4 analog dome camera. The overall result is similar to an IP camera, though the image is not as detailed. Where the previous slide highlighted facial features, this analog picture can still enhance the light on the outside of the building with a sharp image and a reflection that is coming through the entrance door. There is still a need for analog within the industry. Typically this is related to cost. The main thing to know is that WDR technology is still available in this segment of the market. I hope this brief overview into the technology of wide dynamic range and how it is applied to a CCTV camera has been beneficial, with the visual examples of where this technology is able to better display images than non-WDR cameras. Would you like to know more? Information including brochures and data sheets may be found by visiting our website. Subscribe to the Alarm Call Pulse to receive new product information automatically, or register online to receive full access to our e-commerce platform, including pricing and order placement. Contact your nearest Alarm Corp representative. Jeff Rushton for New South Wales, ACT and Queensland, Diane Brazil for New South Wales, ACT and Queensland, myself, or Stephen Dinger for Victoria, South Australia and WA. We are also now can be found on Facebook, LinkedIn and Twitter. Alarm Corp will be conducting regular webinars for the remainder of the year. Every third Thursday we will be holding an intrusion-based webinar, and every second Wednesday a CCTV webinar. To register for any future webinar or view any previous webinar, please visit the Alarm Call website, click on Resources, then Webinars. When you attend one of our webinars, you will have access to special promotions. For all purchases made online through our e-commerce platform, please enter the promo code as shown on the screen during checkout to receive an additional 10% off your already discounted trade prices. This applies to nearly all Alarm Corp's product ranges, with a few exceptions as listed. Let's answer some of the questions. If you have a question now, this is the time to type it and hit send. Okay, the first one. What is a typical range for a WDR camera? The range that is typically shown on a datasheet for a camera to be classified as WDR is normally in excess of 70 dB, extending all the way through to 130 dB. Next question. I have seen cameras with a DWDR feature. What are these? DWDR, or digital wide dynamic range features, are not the same as a true wide-D camera. They may have some additional circuitry over a standard camera, but they will not perform to the same degree as a fully compliant ViewDR or wide-D camera. It is basically a manipulation of the digitized picture in the camera. It may appear to make the image look better, but the extra detail will not be there. The cost for these types of cameras should also reflect that. Is it standard for manufacturers to have similar models with the exception of the wide-D function? Yes, a lot of manufacturers have models that are both wide-D and non-wide-D, as this is one area that there is a significant increase in overall performance. Sony, for example, have the SNC DH120, and the equivalent ViewDR model is the SNC DH140. This is a 1.3 megapixel dome camera. Okay. In summary, there are a number of points to be considered when choosing a wide-D camera. The actual installation of this camera and positioning to cover the scene with varying light levels, the specification of the camera or technology in question. It might be advisable to do a shootout of the models that you are considering in a similar environment rather than seeing them operate in a situation that does not reflect your company and its day-to-day operations. Have these capture footage over a period of time that will allow the various light conditions to be experienced so they can be played back and evaluated. An important consideration to factor in for system design is cost. If the situation calls for a camera with wide-D, I'd strongly encourage you to put in the best technology you can afford. A substandard camera will not perform from day one, and it will limit the operation of the entire system. Thank you for attending our webinar. We appreciate the time taken from your schedule to attend today and hope you found it beneficial. We look forward to seeing you at the next webinar. I hope you enjoy the remainder of your day. Goodbye.